chapter 11, and talk about last thing for the course, talk about disasters and disaster planning. Talk about business continuity planning, fault tolerance, and how to respond to security incidents. This type of planning and the things that we set up can determine if something bad happens, whether the company stays in business or not. So it could be our job when we do those things. And lots of things can be different disasters. We talk about in this first module about continuity planning, how to create business continuity plans, and then how to create and test disaster recovery plans. When we create plans, testing them is always a big deal because you don't know if they work until you actually do test them. Same thing that we would talk about whenever we talk about backups. Does the backup work? Well, you don't know until you actually try it. Did you have any data? Do you know how to get the data back when we do backups? So continuity planning, lots of things can happen, and things that are not necessarily expected can happen. Survival of the business may hinge on the plan. Maintain a function of critical responses and then restore it as quickly as possible. Fire, flood, hurricane, tornado. I know that about the time this class started, there was a big tornado in Dallas, where a number of you are. And I saw pictures of a Home Depot that's just absolutely obliterated. So what's going on there? In Roanoke, before I got there in 1985, they had a flood, a big flood. And they had a lot of people that had IT equipment on the first floor or in the basement of the buildings downtown. And they had a lot of IT equipment that got destroyed. And then they had a lot of people that moved IT equipment to the upper floors when we do that thing, when they did that. So what is the threat? In Norfolk and Virginia Beach, hurricanes. Always a threat there. Several times a year you're going to have those. In this area up here, it could be a snow load, or in Colorado it could be snow load. High winds. California, it's a little bit of everything. High winds, no power, fires, all sorts of things going on there. So could be something as simple as a hard drive. Could be a power outage, phone outage, loss of a key employee. The power outage, and we've had a couple people, I've dropped off a couple of times. We had I think it was probably a Network Plus. We had a brief power outage, but it was one of those that Murphy's Law, everything that could happen did. Took a long time for the router to come back, restarted the machine, and Windows decided that was the appropriate time to do an update. So power outage, what if it's an extended power outage? What if the phone system has a problem? What if your ISP has a problem? What if your ISP has a disaster and you don't have internet connectivity anymore? The loss of a key employee. What happens? Network administrator has a heart attack and is hospitalized for an extended period of time. And then risk management, and there, you can buy insurance on the key employees, the high value employees, key employees, I guess they call it. What are we going to do with those guys? Enhance the resilience and ensure the ability to recover is what continuity planning should do for us. The number of plans here, the business continuity plan itself is the comprehensive plan, risk analysis, controls, service restoration procedures. It's the overall overarching, has a number of elements that go along with the business continuity. Business impact analysis, assessment of the critical business functions and how long you can function without them. Disaster recovery plan, the technical plan for specific disaster types, maybe by department, maybe by location, maybe by department location, I guess. If you had multiple sites, maybe that would be the location by the sites, wherever we have. The IT contingency plan, restoration plan for IT systems, and a plan for partial function during the recovery. Continuity of operations plans for a temporary site during the recovery. And some of these, the IT contingency plan and the continuity of operations, this is one that we always go back to. Maybe, cloud kind of looks pretty good for some of these things. Although when you look at it, cloud might not be so inexpensive for some of these things. Depends on how much your IT is costing or how much you want to put in the cloud. But do you want to put some backup servers in there? Then they're ready to go. So what do we want to do with these things? If you have multiple sites, you may want to have your own private cloud that you manage, or you can have somebody manage for you, that you have the virtual machines at a different physical location, but you still own all the equipment. Crisis communication plan, internal and external. Single point of contact for questions and information from customers. So what is the communication plan? Who's going to be responsible for it? Who's going to be members of all of these teams? And keep in mind that you probably ought to have legal as part of these things too, because things that you say can come back to haunt you later on. And the single point of contact for questions. Everybody can't be asking questions. The question's got to go through a single individual. If they don't know, it's I don't know, I'll get you the answer and come back to it. What about a succession plan? Sudden changes of personnel. The CEO or the president or whoever has a heart attack and is no longer able to function in the job. Do you have a succession plan? Worst case, airplane crash, a lot of people are casualties, and that's happened to some companies where they had a number of people going to different locations. What's the succession plan? Who's going to take over those jobs? Are there seconds? Is everybody traveling together so that if that happens, so if you have a major accident, you lose an awful lot of employees at the same time. Business continuity plan, first things to get management buy-in. You were spending money on what might be. It might not be. I guess it depends on whether you feel lucky that day or not, or lucky that year or lucky that decade, that nothing bad's going to happen. The business continuity plan could be like backups. They seem like a waste of time and a waste of resources and a waste of effort till you need it. And then when you need it, if you don't have it, you're probably not going to have a job anymore. Committee with representatives to create this thing from all of the departments. Lots of different inputs, lots of different representation. You're not going to include everything. When you go through brainstorming, one of the brainstorming thing is that everything that anybody says, no matter how strange it might sound, still goes on the list. You can take it off later. But have reps from all the departments. Everybody should have input with these things. The methodology, ISO 22301:2012. And then FEMA also publishes some business continuity plan guidelines. Lots of policies and checklists and things like that at SANS.org also. So the process itself is the step one is to perform a risk assessment, like normal security planning. Create the business impact on it, the business impact analysis on the system. Design the continuity plan, supporting recovery plans, implement and test the plan. Analyze the results, make the modifications, go through the same process again, do refinement, and you should go back and after you make the changes, do the refinement, go back and test it again. It's going to take time. But if you need these plans and you don't have these plans, then you probably don't have a business anymore. So the little continuity life cycle up here, identify risk assessment. Step 2, analyze the business impact analysis. Step 3, create a strategy and plan development, and then test, train, and maintain on it. This is a flow chart for the steps for these things. The business impact analysis. Develop a questionnaire, conduct a workshop to instruct business function process managers how to complete the BIA, receive the complete BIA questionnaire forms, review the questionnaires, conduct the follow-ups, then the recovery strategies, identify and document resource requirements based on the BIA. Gap analysis, determine gaps between recovery requirement, current capabilities, and then plan development, develop the plan framework, organize the recovery teams, develop relocation plans, write the business continuity and IT disaster and recovery procedures. Then test and exercise, develop a testing and exercise, so we're going to test it after all of this development takes place. Creating it, identify functions that are critical to the sustained business operations. What can we not function without? Resources used by each of the critical functions. And then prioritize them. Because, what kind of backups are we going to have? How much money are we going to spend on each one? We're always going to have to prioritize because there is never an endless amount of cash. Identify threats to each of the functions and then the mitigation techniques, much like we talked about early on how to protect the network. The processes are similar. What's the biggest threat? What's the most important thing? What are the most important things? Prioritize them. The threats, what's the biggest threat? Prioritize them. Identify what's going to hurt us the most, and then mitigation techniques for each threat. And then the step 6 here would be, what can I afford? Some of the operational, just an example of what might happen here, operational impact ranking says help desk, cash flow, profitability, portfolio, image, customer satisfaction. What's the impact on each of these activities? Equipment maintenance, and a lot of these are none, may not be none, so they're not going to be in the high area. But here we have server administration, high, highest, high, and high. So, probably a pretty important one. And then management, network equipment are all high. So what are you going to do? Where are you going to put your resources? Where is the planning, the important plan is going to be? This is one that I thought was kind of interesting, how to develop it. And this was obviously a seminar, and a slide from a seminar, essential that all professional firms, however large or small, develop a disaster recovery plan. Did you know 65% of small and medium-sized enterprises don't have a disaster recovery plan in place? 87% of companies that lose access to their corporate data for more than 7 days go out of business within a year. 30% of all businesses that have a major fire go out of business within a year. So, is it important to have a plan? Yeah. Is it easy to make? Not really, but it takes a lot of effort, and it's going to take resources to do that. But if you ever need it and you don't have it, the odds are not with you to continue in business. System documentation, credentials, software keys. How are we going to, if you get back and we're going to restore things, we can probably get copies of the software, but the keys and the credentials that we would need to get into maybe off-site locations, into cloud locations, we need to have those someplace. Reserve resources, replacement parts, redundant systems, alternate sites, vendor list, procedures or contracts for rapid replacement, the vendor list, who did we get our parts from, backup policies, recovery procedures, personnel list. Personnel list is a big deal. Are all the people okay? You need to notify people if they're coming to work, when they're coming to work. How are we doing in the progression? Yes, you're still going to have a job. No, you're not going to have a job. This is when we expect you to come back to work. This is, we need you to come in right now in order to get something running because you're the only one that knows how to do it. So-and-so was injured, and it's your job. Even though they were the member of the team, you're now a member of the team. Who are the emergency contacts for the business itself? Some different kind of, functional areas. The worst of all possible disasters, the entire city your office is located in is struck by a disaster. Are you out of business? And you say, well, that's probably not going to happen. But if you look at right now in California, it's happening. It has happened. Your office burns down. Can you function? There's a biohazard that has made the office inaccessible. Can employees work remotely? Your firm's server fails. Can it be virtualized? Can it be replaced? An important file is lost. Can you restore it in a timely and effective fashion? Just some of the things that could happen when you're doing these disaster plans. What could happen to you? This is another. What are the critical systems? Make a list of the critical systems. What are the threats? What's the response? The response strategy, response action, recovery strategy, recovery steps. Accounts payable, the threats of server failure. The strategies switch over to the backup server. So we have a backup server. Validate the UPS is running. Response, verify the server is down, verify the data has been backed up and is safe. Test the backup server. Start the switch over to the alternate server, and then the recovery strategy, replace the primary server and fail back to the primary server. Verify the cause of the server outage, obtain new server, install the new server, test the systems, and back up the new server. So the processes that we would go through for each of the critical systems. The business continuity plan and the disaster recovery plan, the checklist test. Giving the plan to one or more people to review. Examine it item by item. Tabletop exercises, which are structured walkthroughs. Gather the team to walk through the theoretical disaster step by step. And then simulation, small or large scale response for the test under control systems. That's going to be interruptive to the business if we actually do a simulation, or at least to part of the business while those simulations are going on. Module B, fault tolerance and recovery. And some of these things I think we talked about in Network Plus. The recovery time objectives or the recovery objectives. Fault tolerance, redundant systems, RAID, and how to design backup policies. So we'll look at each of these for a couple of minutes. The recovery objectives here, the recovery time objective, the maximum expected amount of downtime in case of failure. How long is it going to take to fix it? Troubleshooting and recovery itself and testing. How long is it going to take it to fix it? Or how long is it going to take it to get it back online? I guess it'd be a more precise way of saying that. The recovery point objective is how much data are we going to lose? The maximum expected time of which data will be lost in the case of the disaster. So basically, how far back can we go to get the data? In this image, we got the last backup, 4 to 24 hours, 1 to 4 hours, 0 to 1 hours. And then we have the disaster event, troubleshooting window on down. We have restored the data, RTO, recovery time objective, how long to repair it, RPO, recovery point of objective, how far back in time can we go to get the data. So that depends on, obviously, how often we're doing backups. 0 to 1 hours, we're going to have to do hourly backups in order to do that. 4 to 24 hours, we can do daily backups. When is the last backup? When is the last data set that we can actually get to? So fault tolerance and redundancy, and we've looked at some of these things, is the ability to reduce single points of failure. Reinforced components, better components, higher price components. But really, to reduce or to eliminate them, we're going to have redundant hardware to make these things work really well. So that, like the routers, that we would have backup routers that would be able to take over the default gateway. Hot standby routing protocols would do that. Error correcting software on the hardware. Operations at reduced capacity can also help us with these things. Backup parallel components, backup power. Backup power supplies. 2 power supplies typically on a server to do that. RAID storage, redundant array of inexpensive disks. We're going to look at the type of RAIDs here in a couple of minutes. Load balancing. We might have multiple servers running the same website, web pages, and they have a load balancer that sends information, and we talked about round robin. The first request goes to server 1, the second request to server 2, third request server 1, fourth request server 2. We can have round robin. If we have one of them that's more powerful, more capable than the other one, we can use a weighted round robin. But where we go server or customer 1, server 1, customer 2, server 1, customer 3, server 2, so that the one that has more capability gets more information. Clustering is when we put devices together, they all work on the same problem at the same time to get the answer. It shares the processing. My kind of silly analogy for this is that you're riding in a car with a bunch of friends and you run out of gas. And there's a gas station down the block. And you just have to get there. So everybody gets out and pushes the car, except you, of course, because you got to guide it, you got to steer it. But the clustering would be sharing the load. Not one individual is trying to push the car, but everybody's pushing it together. So you're sharing the load, and that's what clustering can do for us. Virtualization, we've talked about multiple times. That we can, it's a file, we can make a virtual machine, we can synchronize to the virtual machine, synchronize the information in real time to it, having a different location, having a cloud, having a different physical location. You could probably even run one in your basement. I used to run a backup server in my basement in order for, until we figured out how to get the stuff off-site to have off-site backups for the information. Alternate sites, cold site, warm site, hot site. If we have one of these disasters and can't continue at the present location, where are we going to go? How much insurance do we want to buy? A hot site, pretty expensive, although you could probably do it with virtualization. But a hot site is everything's there, ready to go. All you got to do is move the people in order to be able to continue with the business. The cold site, you may have a building, you may have the plan to move a building, you may have utilities in it, but you're not going to have any equipment. Warm site is between, I always say between hot and cold sites. You may have some equipment in it. You have a building leased, you might have the switches and all of those things. You may have equipment there, a server there that you would have to bring the backups and put the latest backups in and get going with the system. So replacement parts. So I just did this one, right? Hot spare, ready to go. Cold spare is ready to install. Cold spare could be in the storage room. Hot site, fully equipped. Backup locations at ready in hours. A cold site, space and utilities, no hardware. A warm site, some hardware, but it's not quite ready to go. You have to do some preparation. How much insurance, how expensive do you need? What do you need? How much are you willing to spend on this sort of service? 4 disaster recovery site types. A mirrored site where we have all the information, going to be instantaneous. 30 seconds, the typical RPO, how much data we're going to lose, nothing. Hot site, 30 seconds to 30 minutes. 0, no data loss. Warm site, 30 minutes, 70 to 72 hours. So we're not going to lose any data on any of these things. In a cold site, it's going to take greater than 72 hours to get it online. So disaster recovery types. And this is obviously an estimate from somebody how long it's going to take. RAID is a redundant array of inexpensive disks. What it allows us to do on our server, except for RAID 0, which although we call it a RAID, has no redundancy. What it allows us to do is to keep running. And redundancy allows you to keep the process going. Maybe not at the same rate as you were going before, but keep the same process going. So RAID 0 is disk striping. It has no security benefit, no redundancy at all. It's going to be faster because it's going to write to the multiple disks simultaneously. RAID 1 is a disk mirror where we have a copy on a disk or an array of disks, a copy of all the data. So it gets written twice. It's going to have a faster read because it's available in two different locations. It's going to be a slower write because it has to be written twice. RAID 1, let's say RAID 1 disk mirroring is what we just did. No performance benefits for it. A RAID 5 is striping with parity, allows for one failed disk. But you also lose, and they've got a formula, but what the formula comes down to is you lose one disk's worth of storage, regardless of how many we have. You have to have at least 3 disks for a RAID 5. One of them, parity, is an algorithm or a data store that allows reproduction of the data. If one disk fails, you can keep operating. It's going to slow down. It does slow down, but you can keep operating. And once you have resolved the issue, or not resolved the issue, determine that, yeah, we have an issue here, then you can put a new disk in, a good disk in, and rebuild the RAID 5 array, and the data is restored to the disk, and you can keep operating. RAID 6 allows 2 failed disks. It has 2 parity sets in it, double parity when we do that. RAID 1, 0, nested striping and mirroring. What it does, and I've got some other images that we do these things with. So back to RAID 0, disk striping, no security benefit, no redundancy, requires 2 disks, and it's fast. And in this one, on the first disk, we write block 1 and then block 2, 3, 4. So it splits the data across the 2 disks, writes to them simultaneously. This is going to be a faster read and a faster write. If one of the disks fails, you replace it, rebuild the RAID, and restore from backup. So it does not have any redundancy, even though it's called a RAID. RAID 1 is a mirror, and here A1 and A1 we have a copy. Disk mirroring, slower write, faster read. Have to have at least 2 drives, or we have to have 2 drives, one for each of the data sets that goes onto the system. So we write the data twice to 2 different disks or disk sets on the system. A RAID 5, and we have the parity block here. Striping with parity, 1 failed disk requires at least 3 drives. You lose 1 disk's worth of storage. And go back to the RAID 1, you're going to lose 50% of your storage here because you're storing the data twice. So however much data you have, 50% of it is going to be there. You're going to have it twice. So I mean, in storage space, gigabytes of storage that we have. 3 disks here. The parity allows it to keep running and allows the reproduction of the data on the disk that fails. So requires 3 disks, minimum of 3 disks. One of them can fail. You lose 1 disk's worth of storage. RAID 6 requires at least 4 drives. It has a double parity, and we can have 2 failed disks with RAID 6. Striping with double parity. RAID 1, 0 in this one needs striping and mirroring, and the order 1, 0 is that first it does the RAID 1 and then it does the RAID 0. So first it builds the mirror and then it builds the stripe to do that. So it's going to have the speed of a RAID 0 of a striping without any redundancy, and the redundancy of a mirror. But again, you're going to lose 50% of your storage in the RAID here. RAID failures, a drive failure, mitigated by the proper RAID level. Controller failure, most RAID uses a single controller, so we do have a single point of failure. When we talk about that, the controller failure, if we go back to these, we might have these on a single controller, we might have them on different controllers. So it's mirroring. We could have redundancy. If the controller fails, they both go away. Or if we have them on two different disk controllers, then the controller failure would still be able to operate. Power issues are going to be an issue. Software issues can be a problem. The RAID rebuild stress, the primary reason for RAIDs 6 versus the RAID 5 is we can have two disks. We have the double parity stripe instead of the single parity stripe in order to enable a more efficient redundancy process. Data backups. So we've jumped from RAID redundancy to backups. That the RAID failed, or the disk failed, or the server failed, or we had the flood, the fire, the electrical problem, or whatever else. And I think we looked at the archive bit. We look at the archive bit again here. Maybe. Let's see. Let's go to the root of C and do attrib. You can hopefully see over here the A bit, the archive bit, says that these files haven't been backed up. And these are obviously a lot of hidden files, the boot manager, the page file, the swap files. VCE player here that's in the root, the RAR file. So the attributes, the A bit says that it needs to be backed up. That's archive bit is a big deal in backing up. When we do a full backup, it resets, it backs up all the data, resets the archive bit, says, hey, it's all been backed up. And then we have an incremental that backs up only the files that the A bit's set on, then clears the bit. Quick to make the backups, slow to restore, because we're just doing little increments. And the differential, and we'll go through the process here in a second, the differential backs up files with the archive bit set, doesn't clear it, and then the snapshot quickly captures the system state on a virtual machine. So the backup that we would have is, let's say on, usually a Sunday afternoon, we run a full backup. So we back up all of our data, and all of the archive bits get reset. Everything's been backed up. Nothing has the A bit turned on. On Monday, users come to work, and they make changes to documents. So the A bit gets set that says they need to be, the archive bit that says they need to get backed up. If we use incrementals, we go into the system, we make an incremental backup. It resets all of the archive bits. So we back up everything that changed on Monday. Tuesday, people go to work, do the same thing. Monday night, we do an incremental backup. We back up everything that was changed on Tuesday, and we reset the bit. On Wednesday, everything had changed on Wednesday, on down the line. So it's going to be quicker because we're going to be backing up a little bit of data each day, increments each day. If we have to restore it, we restore the full, then we got to restore all of those increments in order to get back to the actual data that was lost. In the differential, after we did the full and the A bits were set, people come to work on Monday and make changes. We do a differential, we back up all the changes that were made on Monday. Doesn't reset the archive bit. Tuesday, people come to work, do work, make changes, set the A bits. We do a differential backup. It backs up everything that was changed on Monday and Tuesday. Until we get to Friday, everything that was changed on Monday, Tuesday, Wednesday, Thursday, Friday. So it's going to be slower to make as we get into the week, but quicker to restore, because if we have a failure, we restore our full and then our last differential because it's got all the changes on it. Snapshot, capture the system state. Snapshot really associated with virtual machines that we can go back to a point in time. The backup frequency options, a full backup every night. That's what we used to do at Blue Ridge, and we actually had time to do it, and it was all the tape. Tapes are typically still used because you can get a lot of data on them. Full backup, some may be a full backup Friday night, an incremental backup of the other 4 days of the week, a full backup every Friday night, and a differential backup. Once you start the incremental or the differential, you have to stay with that one. You can't do incrementals on Monday and Tuesday and then differentials on Wednesday, or differentials on Wednesday, Thursday, and Friday. If you start with incrementals, you have to stay with incrementals. Differential, you have to stay with differential. So you can't swap in these things. The security, label the media, and it needs to be physically secure, and it needs to be physically secure and stored off-site. It may or may not be encrypted depending upon the storage and how secure the data really needs to be. Secure network transmission if you're doing off-site backups across the network. And there are a lot of those, backing up to cloud storage, for instance. You want to be sure that you're using the physical, the secure transmission media in order to do that. Physical security for the media transport. There are some industries that are required to store these things centrally. Banks, I think, are actually, and brokerage firms and things like that. And they ship them on FedEx or UPS. So how secure is the data while it's in transit? There was one a few years ago that they thought, one of the banks, I think, thought that they had lost a tape in UPS. They're relatively small, and it actually had fallen down behind something in the truck. They did find it, so they didn't have to tell all their customers that, hey, we just lost all of your information, maybe. Off-site locations, the backups should be stored off-site, because if they're not, and we have something happen on-site, and they're stored on-site, then we had the problem, same problem with it. Fire in the NOC, the backup media burns up along with the server that we backed up. Secure disposal is always going to be an issue. Tape, not so much. We can shred tape. We can burn tape. We can get rid of it. Tape does stretch. You need to test it each time you get ready to do a backup, and usually the hardware will do that for you. It stretches. If it stretches to the point that it's unreadable, then your backup's not going to do any good. So it does have to be replaced on a regular basis. So the creating backup policies, what data is important to backup, retention requirements, backup strategy and scheduling, and you can find on the internet. What do? You do a full, because how long you want to keep these things. A lot of them do a full the first of the year, and then a full every week, and then incrementals or differentials on down the line, and maybe keep the first full of the month until the next month on down. There are, again, a number of methods in order to have a full backup strategy available on those things. Plan the data security. Assign personnel responsibility. Who's going to back up? Who's going to restore? Create and apply a backup testing schedule. Did it work? Do I actually have data? And I think I told you guys, I got called into a site one time and said, we're doing backups, we think, but we're not sure we're getting any data, and they weren't getting any data. It's just a matter of going through the process. This was on a NetWare server, which was not the easiest thing in the world to set backing up for, but got it going, able to restore things. We would, at Blue Ridge, it was a Windows system, and it wasn't as difficult to do. We would test backups, and there'd be times that somebody would call up and say, oops, I just deleted a file that I need. Do you have it? So we go to the backup tape and find the file and restore it for them. You're going to have things like that. Backups can become a really big deal for all of these. Windows backups, and this is kind of a step-by-step. Open the backup tool, choose the location, choose the file, set the schedule. You may have done that. You can practice that one on a system if you want to do that, to do a backup, a Windows backup.